Okay, so today we're going to be answering the question, how high does a projectile go? We're going to be talking about how to answer that algebraically rather than needing to create a graph to look at it. In terms of vocabulary, that highest point in the graph is called the vertex of the parabola. So we're going to start just by taking a moment on Desmos to look at the graphs we were looking at in class yesterday. One of the first ones we did yesterday was y equals negative 5x squared plus 15x. And when we looked for that highest point, the vertex of the parabola, we saw that that happened when x equals 1.5. That projectile was at its highest after 1.5 seconds. Another one that we looked at yesterday was y equals negative 5x squared plus 15x plus 3. Notice that the highest point there also happens when x equals 1.5. So the vertex there is at x equals 1.5. That projectile is at its highest point after 1.5 seconds. And we also looked yesterday at y equals negative 5x squared plus 15x plus 20. And the top point there also happens when x equals 1.5. So that was also at its highest point after 1.5 seconds. So observations we can make about this. Every single problem that we looked at yesterday that had 15x in the middle of it had its highest point when x equals 1.5. That suggests that we don't actually care about the constant term when we're asking when is it at its highest point. We should be able to answer that without needing to look at the constant term. And that 1.5 also showed up in our boxes yesterday when we completed the square. So a quick refresher on what that looked like. If we were dealing with negative 5x squared plus 15x equals 0, so when we were looking to answer the question, when does it land, for the first problem that I just graphed, the first step was to divide everything by negative 5 in order to have an x squared at the front with no coefficient on it. That got us x squared minus 3x equals 0. And then that negative 3x got divided by 2 to get a negative 1.5x, which went into the boxes. So we had a negative 1.5x in the box, and our highest point happened at positive 1.5x. So what this means, if we have an equation in the form y equals ax squared plus bx plus c, then the highest point happens when x equals negative 0.5 times b over a. So b over a is that step where we did 15 divided by negative 5, the x coefficient divided by the x squared coefficient. Multiplying it by 0.5 is the dividing by 2 step. And then the negative out front is to get the opposite of it, because we saw that when we had a negative 1.5 in our box, we had a positive 1.5 for the highest point. This would be a really good place for you to pause the video and write this rule down into your notes. All right, ready to continue? We will look at an example. So if we have y equals negative 5x squared plus 20x plus 4, the first thing we want to do is identify a, b, and c. A is negative 5, b is 20, c is 4. And then we'll remember our rule. We're looking for negative 0.5 times b over a. Plugging in the values we just found, that's negative 0.5 times 20 over negative 5. 20 over negative 5 is negative 4, so we've got negative 0.5 times negative 4, which is positive 2, which means that this projectile is at its highest point after 2 seconds. This would also be a good place to pause the video and write this down into your notes so that you have an example you can follow. All right. Now that you're back, we're going to take a moment to check that on a graph. So we were looking just now at y equals negative 5x squared plus 20x plus 4. And that highest point there does indeed show up when x equals 2. So this is at its highest point after 2 seconds. So we've done good. All right, but how do we know how high it goes? Let's remember that the height is y. So if our original equation was y equals negative 5x squared plus 20x plus 4, and we just found out that it's at its highest when x equals 2, we can plug this in. So that y equals negative 5x squared plus 20x plus 4 can become y equals negative 5 times 2 squared plus 20 times 2 plus 4. Following the order of operations, we're going to deal with that exponent first. 2 squared is 4, so the equation becomes y equals negative 5 times 4 plus 20 times 2 plus 4. Then we can multiply. Negative 5 times 4 is negative 20, and 20 times 2 is 40. So we've got y equals negative 20 plus 40 plus 4. Adding left to right, negative 20 plus 40 is positive 20, so y equals 20 plus 4, and y equals 24, which means that the maximum height of this projectile is 24 meters. Hopping back to our graph for a moment, we can see that we do have a y value of 24 there. So after 2 seconds, this projectile is 24 meters high, and that is its maximum height. This right here is another good place to pause and copy this worked example into your notes. All right, we just checked on the graph again. So to summarize what we've just done, to find when the projectile is at its highest point, we use x equals negative 0.5 times b over a. To find how high the projectile goes, we plug that number into the equation for x. This is a good place to pause the video and make sure that you have both of these sentences written down in your notes. All right, and we'll wrap up with one more example just so that we've got it all in one place for one problem. So for our last example, we'll do y equals negative 5x squared plus 13x plus 7. We'll start by finding when it's at its highest. So we need to use x equals negative 0.5 times b over a. Plugging in, b is 13, a is negative 5, so we've got negative 0.5 times 13 over negative 5. 13 over negative 5 is negative 2.6, so we've got negative 0.5 times negative 2.6, which is positive 1.3. So this projectile reaches its maximum height in 1.3 seconds. To find how high it goes, we then need to plug that back into the equation for x and find y. So we have y equals negative 5 times 1.3 squared plus 13 times 1.3 plus 7. Following PEMDAS, we do the exponent first. 1.3 squared is 1.69. So we have y equals negative 5 times 1.69 plus 13 times 1.3 plus 7. Multiplying, negative 5 times 1.69 is negative 8.45, and 13 times 1.3 is 16.9, and the 7 comes along for the ride. Adding left to right, negative 8.45 plus 16.9 is positive 8.45. 8.45 plus 7 is 15.45. So this projectile's maximum height is 15.45 meters. This is the end of the video. This would be a really good place to pause and make sure that you have these notes written down. And I would also recommend that you take a moment to check this on Desmos yourself.